So if you do find duplicates, this typically points to one of the issues that you see here on the slide. Duplicates can be optical duplicates. This happens when one cluster is falsely called as two or more clusters, and this typically happens when a cluster is formed on the border of tiles. So it will be called multiple times, once for every tile. Also, in the middle of the tiles, oddly shaped clusters can be called as two separate clusters. This issue does not happen on pattern flow cells because on these flow cells you can control where the clusters will form. They will form in the wells. Duplicates can be library duplicates, and then they are generated by PCR during the library prep. So the PCR will copy the fragments in the library, and different copies from the same fragment will end up in different clusters and will be sequenced multiple times. But they will represent the same fragment from the library. Or duplicates can be clustering duplicates, and this only happens on pattern flow cells. So in pattern flow cells, you have these little wells here. So long fragments can form bridges to neighboring wells. So these wells will contain ultimately the same fragment from the library, and it will be sequenced multiple times. So duplicates are unwanted because they distort the counts. In variant analysis, you are going to count the number of times that a mismatch occurs in your reads. So if it occurs multiple times, you are going to decide that it's probably a real variation, so a SNP. If it occurs only once, then it's probably a sequencing error. You don't want to count technical duplicates multiple times here. If these three reads are technical duplicates and you're going to count them as 3, then you are going to conclude that this mismatch is a real mutation. However, if they are technical duplicates, they originate from the same fragment in the library, so you should count them only once and conclude that this is probably a sequencing error. So to avoid distorting the counts, the duplicates are removed from the FASTQ file. And the same is true for ChIP-seq analysis. In ChIP-seq analysis, you're going to count the number of reads that align to a certain region in the genome. And you are going to compare the counts in the ChIP sample to the counts in the control sample to find regions that are enriched in the ChIP sample. These are the regions that are bound by the transcription factor. So also here, you want to count technical duplicates as 1. And this is a real issue because ChIP samples often contain a lot of duplicates because they are typically small libraries. Not that much of DNA will be bound by a transcription factor. So to get enough signal during the sequencing, you will have to do a lot of PCR amplification of these small libraries, hence leading to the generation of a lot of library duplicates.